Share screen. Okay, hi everyone. Good morning to you. Apologies for having this class at this time. It's just the way we have to manage it at the moment. And today's class is even though Dapo wrote Introduction to Terraform, but for me, I say it is Terraform the right way. And I also shared with you yesterday that you should go through the prerequisite of the what's it called of today's class, because that class was Introduction to Terraform. So if you have gone through the prerequisite of the last class, it should be very easy for you to follow on through this, because that class basically the video I shared with you basically explained the basics of Terraform for you, the little things you need to understand, something like that. So please, can you mute yourself if you're talking? So to start with, I am going to say that, is there anybody here that has not gone through the prerequisites? Anyone, please?
Yes,
I mean,
I haven't gone through it.
I've not gone through it, sir.
So
For
you
me,
have
I
mentioned
went
have
through
not
it,
gone
but
through it.
not till the end yet.
What did you say, please?
I went through it more than halfway, but not till the end yet.
Okay, it's fine, no problem. So it's fine, but it's important that you go through, but nonetheless, I'll try to recap a few things regarding the class. Okay, so today I am basically going to build on the previous lesson, like I said, although I will try to give a short introduction referencing the past class. Then I will talk about managing Terraform states, which is so important. I will also talk about creating reusable Terraform modules. And finally, I will also get to talk about secrets in Terraform. That is, how do you manage secret in Terraform? Then I'm going to end it in a conclusion. Everything here is all around getting to use Terraform the right way, using the best configuration approach. That is it. So introduction. Terraform basically is an infrastructure as a code, and this is a tool that makes it easy for you to provision cloud resources on your environment. And in the advantage of this is that it makes it easy for you to manage your infrastructure resources, cycle of that resources. We have a lot of infrastructure as code tool, which you can see on the right-hand side of the screen. We have tools like, Chef, we have tools like Puppet, we have tools like Vagrant, AWS, CloudFormation, and so on. And all these tools are targeted to achieve different purposes. Some of them are for infrastructure provisioning, which has to do with Terraform, for example, CloudFormation, for example, Google Cloud Manager, and also Azure Resource Manager. Some of them has to do with, configuration management, talking about Ansible, talking about, Puppet and so on like that. These are some of the things that we have that, these are some of the ways in which we can use infrastructure as a code. But today's class is basically focused on Terraform. So now, how do Terraform come about? How do we go about with Terraform? In Terraform, just like the way you have for everything that has to do with a code, it must always have a language which you can use to interact with it. Just like the way we have Python, we have JavaScript and so on like that. So similar thing applies to Terraform. For Terraform, we make use of HCL, HashiCorp Configuration Language. And HashiCorp Configuration Language is one of the simple language that you can ever use, because it is very, very, straightforward. In HashiCorp Configuration Language, basically we deal with a resource block. And that block has to do with, you talking about, can you see, let me use a pointer. I don't know if you can see a pointer here. Laser pointer. Okay, can you see my pointer? Hello, can you?
Yes, I can see it.
Okay, good. So if you look at this now, this is a simple way we have the HCL language. It basically has to do with, the block type, the resource type, and the resource name. Then for everything that is within the block, we have the block body, which has to do with, an argument. But before then, I also need to talk about installing Terraform. To install Terraform, you can go to Terraform website, just follow the installation procedure, and you can successfully install Terraform. Now, in this example now, you can see here that I use Terraform to create a local file. I call the file welcome.txt. Then I put in a content called welcome to Terraform class. And this is the resource block that was used to create that particular file. So basically, it's still following this syntax, which has to do with what is the block type? The block type is a resource, right? What is the resource type? The resource type is a local file. What is the, what's it called? What is the resource name? The resource name is welcome. Then what is the block body? The block body consists of the content and file name argument. This is just HCL. Now, we have different types of block type in Terraform. I am going to explain that in the next slide, but this is just to, let you let you understand what you call it, how HCL configuration language is. Now, at the same time, there are many common commands that we have in Terraform. Please, can you mute yourself, please? Please, can that person mute himself? Dapo, can you help me mute the person? Okay. So in Terraform, there are basically 4 commands that are mostly used in Terraform, even though we have a lot of commands. The first command that we have is Terraform init. Terraform init, basically what it does, if you look at this, it does 2 things. The first one is that initialize your backend, which I'm going to talk about. What is the backend? I'm going to talk about it. And it initialize your provider plugins. What is a provider plugin, or what is a Terraform provider? I'm going to explain it to you, because for everything in Terraform, you need to always have a provider. Provider plugin basically looks like it basically means what we call what we call the more like an API in which Terraform used to interact with that the owner of that particular resources that you want to create. Now, in this place now, you will see that I am creating a local file. And my resource type is what? Local file, right? Now, if you look at the plugin that was initialized by Terraform, you will see that here we have installing HashiCorp.local. That is to tell you that this is the particular plugin that Terraform is using. So the third thing that happens is that when you run the Terraform init command, your Terraform init command also creates a lock file for you. That is what we call the .terraform.log.hcl. What this basically does is that the moment you do this, it creates that log file for you, which can help you, lock the state of your file to avoid, changes or any other thing. I'm going to explain more information about, locking in Terraform in my next slide. But for now, I want you to know that when you run a Terraform init, it does 3 things: initializes your backend, initializes your provider plugins, initializes your it creates your Terraform lock file. Now, the next thing that follows when you run a Terraform init, it's a Terraform plan. This is just an introduction, just previous, just like the way I showed you in the last, in the video I gave you, just to, run through. Your Terraform plan is the next thing that you do. When you run your Terraform plan, this basically gives you an overview of what your changes is going to be. That is what is going to be provisioned for you. This is what a Terraform plan is. And if you look at this, running the Terraform plan for this small resource block provide this. Terraform plan will always come with 3 things: resource to add, resource to change, and resource to destroy. Now, because this is being run for the first time, it is showing you that what? This is the resource. I'm adding one resources, which is just this resource. It's not changing anything and it's not destroying anything. Are you there? Now, another thing that is in Terraform is that when you want to make changes, when you are seeing changes in this place, maybe there's any changes in Terraform, there are two types of changes. There are some that has to do with force replacement, that it has to destroy that resources and recreate that resources. One. The second one is in place updates. That is, that particular argument in that resources that you are changing does not have to do with recreating the whole resources again. An example, if I have this file, maybe for example, I have web provision this local file now, and when I want to change, I want to change the file permission. Now, this time I want to change the file permission to, let me say, 555. We all know file permission in Linux. This is just the same thing. I want to change to 555. Such changes will definitely not require Terraform to recreate the resources again. It is in place update. I hope you get me. So when you also run your Terraform plan, before your Terraform plan is provision, before your resources is provision, Terraform does what we call acknowledgement. It tells you, do you want to approve this plan? The moment you enter the value yes, that is when Terraform will start creating that resources. And you can then start to track it, that you can start seeing creating in maybe 1 minute, 2 minutes down until you see creation complete after a particular time. Are you there? Now, finally, how do you now see the resources that Terraform has provisioned? We have the resources by running Terraform show command. This will just give you similar thing to what you have here, but this time with the resource and full details of this place. You can see here, for example, you can see in this place we have ID known after apply. But after you have run the Terraform apply command and you have provisioned it, this is supposed to be applied, not Terraform plan. This is supposed to be applied. After you run your Terraform apply command and you have provisioned it, then it comes with a resource, what do you call it? A resource ID, which is what you now see here. This is just a little introduction. Any question on this command before I go to the next slide? Any questions so far?
I don't think there's any.
This is the basics.
No, sir.
Thank you. Thank you. Just a minute, please. Now, Terraform configuration directory. How does a Terraform configuration directory looks like? In a Terraform configuration directory, first of all, we have, I'm coming, oh my God, I'm coming, just a minute, please. Okay, we have 4 types of configuration of files in the configuration directory. We have the main file, main.tf, we have the variables, we have the output, and we have the provider.tf file. Now, remember in this slide, I told you that we have a block type, right? Now, block type in Terraform is similar to some of these things that we have here. In Terraform, we have block type such as resource. We have block type such as variable. Can you see this? Variable. We have block type such as output. You get me? And we have block type like, local, and as well as, what's it called? We also have data. That's like the common block types that we have in Terraform. Now, what does a main.tf file do? What does a variable.tf file do? What does an output.tf file do? What does a provider.tf file do? A main.tf file is where that particular resource you want to create is being defined. That is where you have the definition. This basically here is a main.tf file that you can see here. It shows that I am provisioning a local file, and this time I am passing, instead of me writing it like I have it here, like, okay, this is the particular value. This time I am passing it as a variable var.content. But nobody knows what this var.content is, right? And at the same time, nobody knows what this var.file name is. In order to do that, we need to create a variable that will reference the values that should be here. That is when the variables.tf file comes in. So the variables.tf file is basically going to reference what you call here. And this time, you can now say, okay, variables file name, for example, should be of a particular type, maybe string type, and there are different data types in Terraform as well. We have string, we have set, we have list, we have, a lot of things, dictionary and so on. So you can then pass a default value to it. And this default value is going to be a value that will be referenced anytime it sees what? File name. It will always replace this file name with what? Introduction.txt. And the content will then also be replaced with what? Welcome to Terraform class. My name is Nurudeen. This will always be replaced. Now, what are the advantages that this guy gives you? This guy gives you the advantages to be able to have variables, different types of variables for different environment or for different purposes without you coming to touch your, to touch the main file itself. Say, for example, I want to change, maybe create a new file now. Maybe this file is just, daas file, and I want the content to be like, this is daas 2023 class. All I have to do is just to come here to the variables and, specify a new default value for it, and it goes in. Now, I am still going to talk more about assigning variables. But before I go that, let me now talk about output file. A Terraform output file is basically the output of your command that you run. Like, let me say something that you are interested in when you run that file. When you run this file creation, that is what an output file is. So in this case now, remember that when you provision, I'm taking back to the backslide, this previous slide. When we provision this file, we have a lot of things that are associated with file, right? We have content, we have directory, we have permission, and so on like that. But imagine that maybe I need only the file permission or the file name. I just need that in the output. You get me? What I can do is I can create an output file and say the particular value of what I need. Now, how do you create output file? The output file is created in such a way that it needs to reference the resource type, the resource name, and the arguments. What do I mean? In this place now, I am creating a output of a file permission. So the first thing is that, what is the resource type? The resource type is local file, right? What is the resource name? The resource name is welcome. And what is the particular variable attribute that I need? It is file permission, which is what is here. So maybe, for example, I need another one. Maybe I need the file name. I need this is supposed to be file permission. And maybe I need like file ID, for example. In that case, it's going to be local file welcome.id, which is referencing this ID. I hope you get it. So this is the way output works. Finally, Terraform provider. Like I mentioned to you, for every resources that you want to create in Terraform, you need a provider. If you don't specify a provider, most of the time, Terraform will use its local providers. What do I mean? I also explained to you that providers allows you to interact with cloud resources providers, or that particular type of resource that you want to create. And we have different types of providers. We have, the cloud provider, the SaaS provider, and the API provider. An example of this thing that we created, for this guy, we are using a provider called HashiCorp.local, and this is what we have. Now, a quick question you should ask me is that, where am I getting all these things from? How do I know how we should be? Because like I tell you, I teach people to fish. I don't give you the fish. Now, there is what we call the Terraform registry. A Terraform registry basically is just more like an environment where you have documentations on how different resources can be provisioned, and at the same time, how different providers can be specified with the configuration that follows. To do that, let me go to the environment. Can you see my screen, please? I'm
Yeah,
coming.
Yes.
I moved this guy the last time somewhere. Okay. So if you go to if you just type on Google, okay, this is just Terraform registry. I'm just going to go to the default page. You can see here, it says Terraform registry. You can discover what? Different providers and power for all Terraform resources, type, and different modules, right? Now, if I click on browse providers, you can now see different providers here. Now, providers are distributed into 3 categories. We have official providers. Official providers are the ones that have the Terraform stuff. These are like Terraform official providers. We have partners, which are basically like partners provider. And the last one, which is more like, what me and you can do, is the community provider. For official provider, you always see this on their head, which is official. An example is AWS provider. Now, this basically means that, this provider is official by AWS. Partner is what is created by AWS partner. And for most official providers, they are usually provisioned by AWS. By HashiCorp. So maybe we click on maybe Google Cloud, for example. Now, you will see Google official by what? HashiCorp. HashiCorp owns AWS, owns Terraform. Let's click on AWS again. You see HashiCorp AWS provider official owned by HashiCorp. The same thing goes for Kubernetes and so on like that. That is the first one. Now, let us filter out and look for partner providers. Partner providers are more like, the Terraform partners that try to create, different stuffs in the Terraform registry so that me and you can use. You get me? You can see an example here is JFrog Artifactory. This is a provider. This is just a provider that allows you to be able to create JFrog Artifactory, basically used for CI/CD. This is just to store artifacts. I believe that was talked to you about artifact in the last class, where he mentioned to you, what artifacts are and so on like that. So, for example, here you can see this is a partner, and you can see that it is provisioned by what? JFrog. Now, community provider are me and you. These people are just individuals. I can do a lot of things. I was working on one some time ago. I think I was working on Postgres. I was trying to create Postgres some time ago. Yeah, this guy. I was trying to create Postgres, and I saw that this guy worked on this guy. I know this guy. So he created a module. You can see, even published 3 years ago. He created a module for Postgres, or a Terraform provider for Postgres. So this guy, for example, is a community provider. So if you are good very well and you want to have providers in Terraform, you can always create providers in Terraform, what you call it, Terraform registry. Now, all these things that you see here, for every provider, there is always a source code behind it. When you click on the source code, it will always take you to the Git repository, where you can see the different things the person has done. Look at the code base. If you want to add something, remove something, blah, 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 depending on, just to understand how to use the provider more, this is where you can see it. This applies to every provider, be it official provider. This is AWS official provider as well. Be it official provider, be it community provider, or be it partner providers. Now, what is the next thing that you can see in the Terraform registry? When you go to, don't forget that I'm coming from here, please. Don't forget I'm coming from here. I'm asking you people, I'm asking myself, I'm answering the question, how did I get these stuffs? How do I get to know it? Now, for every resource that you want to create in the Terraform, if you say, for example, I want to create an AWS resources in Terraform, when you go to the provider page, we have three things. Overview, which is what you're always seeing, documentation on how to use the provider, and documentation on how to create resources using the provider, and finally, how to use the provider. The first thing that you need to note is that for everything you want to create in Terraform, you need the provider file. So for example, if I want to create an AWS resources, I need a provider file that looks like this. Now, the syntax for this is different. All you just need is Terraform, required provider, put in the name of the provider, which is AWS. It has to match this name, AWS. Then you need to put in the source and at the same time, the version. This will always be seen anywhere. Then you can now add some extra provider configuration. So for me, for example, I am using local provider. So for my local provider, you can see that I am using the source HashiCorp.local, the version 2.23, which is a old version. So how do I want to find that provider? If I go here, I can basically find local. You can see HashiCorp.local. And if you click on this, this is similar to what I have in my environment. Now, you can see local provider is used for providing what? Local resources such as what? Creating files. Now, the next thing is now that, okay, I know how to create my provider file. How do I now create a resource? For every resource that you want, for every provider, there is always a documentation that shows you what are the type of resources that you can provision or that you can create with that provider. Let's go to documentation. Now, in documentation, I told you that, remember I told you here that we have different block types. Sorry. I told you here that we have different block type. I told you that we have the resource block type, the data block type, the output, and so on. So in most providers, you are usually having the resource block type and the data block type in most providers. This is what I'm talking about here. Resource block type is basically resources that you want to create. Data block type, or let me say data sources, is basically getting information from something that's already been provisioned. Do I make sense? Getting information from something that's already been provisioned. That is when you say data block type. Now, here now you can see in this place now, I have two resources that can be created with this provider called local. The first one is a local file. It says generate a local file with a given content, right? This is similar to what I did, right? And in everywhere you always see, an example with attributes and so on like that. Now, let me use something that is a bit complex. Let us go to AWS, or let me say Azure, for example. Or let me even say Kubernetes. I think you have taught Kubernetes. Okay, let me use Kubernetes. Now, look at Kubernetes documentation. We have Kubernetes providers talking about different things that you can do in Kubernetes. Now, let's say, for example, now we want to create a pod, a Kubernetes pod. Now, to create a Kubernetes pod using Terraform, all you need to do is, first of all, define your provider. You can see the way the provider looks like. If you want to add extra provider configuration, like, config, kube config and so on like that, you have to add it here. You get me? Then, how should it look like? This is basically how the resource definition of a Kubernetes pod looks like. Basically, it goes with the resource, that is the type, block type, the resource name, which is Kubernetes pod, the resource type and the resource name. Then you can also see, some other argument that is passed into it. This is an example of how to do it. Now, how do you know this argument? In every provider page, you always see what we call argument reference. Argument reference here will give you more information about argument and the supported types of strings or so on that they follow. This gives you more details about how you want to do your what you call your resource provisioning. This is it. Even for example, if you go to AWS or maybe Azure, for example, you go to AWS. Let me say I want to probably create anything on AWS. Let me say I want to use CloudFront. I want to create CloudFront, for example, CloudFront distribution, for example. Now, CloudFront distribution is what I want to create. In every Terraform, you always see that what you have an example of how to create that CloudFront distribution, which is this here, because here the reason why we have S3 bucket here is because CloudFront requires S3. But this is just like the CloudFront distribution and how to create it. And this is also passing some extra argument to that particular resource that you want to create. Now, for everything, you always see the argument reference here. What are the things that you can pass to it? It tells you can pass this to it. It's optional. This is optional. It tells you the one that is required, like this is required. So, for example, if you are creating a class for distribution and you're not passing default cache behavior, it will fail because it is required. So you can see some are optional, some are required. And it's also probably going to specify to you, let it be a set or maybe a string or whatever if necessary. You get me? So this is how what is it called? Well, these are the information that you can get in Terraform registry. Another thing you can also get in Terraform registry is attributes. Attribute basically tells you what are the things, what are the attributes or what are the things that are created after you create your resources. For example, if you are creating a CloudFront distribution, you cannot specify the ID, but after that resources has been created, you will notice that an ID will automatically be created. Similar to the way I have a local file here. When I was defining it, I did not pass in file permission, file name, or ID. But after it was created, this was created alongside this. This is an attribute. And this attribute, from this attribute, I can reference my, my output, that particular output that I want for my, for my Terraform, Terraform code block. So the same thing happens here. Attribute is just what the information that you can get from such a resources that you have created in Terraform. So if you are creating like, an AWS resources, you always have ID, ARN, and some other things that, goes along with it. So this is just a documentation on how to use Terraform registry. You cannot know Terraform without knowing how to use the registry. A good understanding of the registry will make it easy for you to provision any type of resources in the world. You don't need to memorize all these things. Examples are always in the registry and with information about the argument reference that you need for that resources. Down, back to this. Any question?
Yes, I have a question based on the output file.tf. When you say you will, for the value, it's for like your value, you include the resource type, and for the other, for the welcome, you include the what do you call it here? Sorry, the file name. In this permission file permission, because in most cases I always see ID. So I don't know, this is where my problem lies in Terraform, this output aspect, because I don't really understand this very well.
This
Why
out,
is it
I don't understand. What exactly is your question? I already mentioned that this is a mistake. This file names, this is supposed to be file permission. I explained this, but I can also have file ID here, but this time I'll be referencing this guy, ID. Yeah, you get me. So in that case, I'll be having local file.welcome.id.
Okay, sir. Okay, sir, but if you are having so many resources, how would you do this?
If I'm
If you
having so
want to
many
provision,
resources,
if you want to provision so many resources,
and what?
how will you pass the output to match
How?
the all the resources?
Thank you. Output is basically what you need from a resource a resource that I want to provision. That is what you need to be displayed from a resource that you want to provision. And we basically use outputs maybe when you want to reference that resource in another place. It's basically more useful when you are creating a Terraform module. You understand better when we get to Terraform modules. So, for example, I am creating this guy. I'm
Yes.
creating a file. Maybe, for example, I need the permission in another place. Maybe I want to probably create another file or let me another resources that require to know what is the permission of this guy. So maybe we want to put a condition that if the permission is 7777, that is read or everybody read, we can say, okay, maybe make the file private or accessible. For example, you get me now, or maybe make the output sensitive or not sensitive. You can use it for different conditioning. You get me now. But you only need output when you want to reference it somewhere else. That is the basic use for it. Did I answer your question? Well?
Okay, sir.
So maybe you are running a script, for example. You are not interested in what the script want to give you. You just want to see what is the output. You get me now. Then
Yes.
you can get to know, okay, this is the file name that was created, this is the output I need, so on, that's it. So back to this example, for example, now, maybe in this place now, assuming that you created a cloud, what do you call it? Let me show you this guy. You understand what I'm saying now? See, where is it? Where is the example I want to show you? Okay, good. Now, let me show you what I'm saying here. Look at this. Can you see my screen?
Yes, sir.
Okay, you can see my screen, right? Now,
Yes.
in this guy that we have here now, look at what we have here now. This guy
Yes.
is creating a, what do you call it? A cloud fund distribution, right? Now,
Yes.
but before he created that cloud fund distribution, it's created a S3 bucket, right? Pass some
Yes.
stuff to S3 bucket, right? Can you see this is a S3 bucket?
Yes.
Now, one thing about what was it called it? AWS is that look at when you want to create S3 buckets, you get me? Every S3 bucket, after you create it, always have a regional domain name, which is needed for these cloud funds. So this is S3. This is the definition of S3, right? You create S3, pass the bucket name, pass tag, right?
Yes.
Now, this guy now want to create a cloud fund distribution. And when you are defining the origin of a cloud provision, you need an S3 domain name. This time is now referencing AWS S3, right? Which is the resource type. Then B, the resource name, and going to reference that attribute block regional, bucket regional domain name. You see that this thing is not here, right?
Yes.
But it is an attribute that is created automatically when you create your X3. Let me go to X3. Let me duplicate this tab so you understand what I'm saying. Duplicate X3 bucket, right? Attributes. You see this guy? You see this?
Yes.
Do you see?
Yes.
It is not an argument, it's an attribute. So, for example, now it says the bucket region specific domain name. This will automatically be created after you create your S3 bucket. This is an attribute. Now, this guy needs that attribute in this environment. So, for example, what he can say that maybe when he runs this guy, for example, he can say, okay, he needs what does he call it? An output in his Terraform command that will show him just this bucket regional name. So you understand me now? So in that case,
yes,
you can create Terraform output and the value will just be this guy. Just be this guy, value. It just be just like the way I have it here. Value will be equal to local dot blah blah blah. So you can just put it like this. And maybe here you can now come and reference it here. You understand what I'm saying? So that is
yes, sir.
how it works. Do I understand? Did I explain it very well to you?
Yes, sir. Thank you.
Any other question? Okay, good. Now, finally, assigning variables to Terraform. There are basically 5 ways to assign variables to Terraform and take precedence as you have seen. You can assign variables to Terraform through interactive mode. Take, for example, we are still going to do commands and just try. This is an introduction of the last class and the prerequisites, just to show you through. Take, for example, we have this file, and now I have created a variable var.content, right? And in my variable file, I did not put any default for it. I did not put any default. You get me? I did not put any default. Such definition like this, when I run it, Terraform will ask me interactively that, okay, what is the name of the file name and what is the content I want to put it? That is interactive mode. Did I explain that very well? Another one, environment variable. Environment variable also happens. For example, you can export these file names and the content as an environment variable within your local system. And when you do that and you do not put a default value here, Terraform will automatically ask you again interactively that what do you want to assign to this value, content, and file name. But this time you will not put anything, you just press enter. Automatically, when you press enter, Terraform will go and reference the environment variable on your PC. Other ones which also look alike is variable definition file. I'm going to show you an example of a variable definition file and also a auto TF-vars, that is TF-vars. They are similar. This time as well, it's just good when you use these two when you have multiple environments that you want to manage. Maybe, for example, you want to create this file and you want this file to be for different teams. You get me now? This same file, you want to have one for Team Cloud. You have one for Team Container Champions and so on like that, Pipeline Ninjas and so on. So you can have a TF-var file that has, a TF-var file that has the different resource name for everybody in these different teams. What I mean is that in your TF-var file, all you just have to put is file name, say, okay, file name, Team Cloud, Team Container Champion for different files. And once this is provisioned, it will go and pick the particular TF-var that is peculiar to each team and create different files for them. Then variable vibe command line is also, passing the variable through the command line. You get me? So these are the different ways that you can, assign variables to Terraform. Now, any question before I go to the next slide? This is just introduction on the last class. I hope we all get this. Now,
Yes, sir.
thank you. Let us now do Terraform the right way. Managing Terraform state file. What is a state file? A state file basically is a record of what you have created for your Terraform resources. That is what a state file is. A record of what you have created. Say, for example, when I run this guy now, if I try to create a file running this guy now, let me do it. Let's do this. Let's do this together. Now, let me go to my command line. Let me go to test. Sorry. Okay, now, and what do I limit that you have providers? Not here. Okay. Oh, no, I don't want to touch it yourself. I'm coming. I'm going to show you something. Okay, good. Now, I created a file here called test, right? Now, provider.tf, variable.tf. I want to explain state file to you and the way state file works. You get me? Now, let's say I want to create a provider.tf now, which is basically you want to create that what's it called? Let me that same local file or anything that I want to create. Then using the same required providers. Sorry, this is local. Okay, now this is a provider.tf file. Can you please mute, please, if you're not talking? I've explained this to you, right? Now, I want to create a resource, which is just that resource that we have in the screen below. You get in local file, then test, something like that. Then content. What's missing? Am I missing something? Okay, good. Now, then variables. What's the name of the variable I created? Sorry. Test file content. Okay. Okay. Are you with me? The second one is test file content, test file permission. Okay. Looks good, right? Controls, what is on there? Test file content, not the test file content, then no, this is not permission. This is supposed to permission. This is supposed to be, I think, where is our local? I think it's supposed to be local. That's why you need this guy. The resource definition, the attribute is local file, content and file name, sorry. So, content, file name. Okay, good. Information. Okay, good. Okay, good. Now we have this, right? Now, there is no default passed into this guy right now. Are you there? Hello? Hello?
Yes,
Yes, you are with you.
There is
we
no
are here.
default passed into this guy, right? Now, I can go here now, right? And first of all, I have a command I used to use. I call it Terraform format. Terraform format is basically just going to help me format my file to make sure that everything is fine. You can see everything is fine. There is no problem or anything. Now, then the next thing is going to be, what's it call it? It's going to be what's it call it? Terraform init command. Now, you will see that this is doing the same thing I told you it's going to do, right? Init initialize successfully, correct? Now, let me clear my screen. And then, sorry, let me push this guy to the side. I don't know how to push this guy to the side. I cannot put it up. Then, Terraform plan, right? Let me just check TFP. I have here this thing for them. Now you can see that because I did not put values for this guy, It's asking me interactive. This is true interactive mode. That what should be the content of the file, right? So let me just say welcome is the content. It's asking me what's the file name, right? That's file. That's fine. Now, Terraform is telling me that, okay, I am going to provision this. You see now? But this time, this is what I pass to it. And it is going to provision all these guys for me, right? Giving it a permission, putting it in this directory, and so on like that. You grab. Now, I can then run Terraform apply. Okay. Terraform apply, passing the same information that I passed to it before, which is what you call it, the name. I'm just using this as an example. I can automatically make it default. You get me? So I'm passing the same information. Welcome. What's the name of the file? We call it daas file, right? So it's asking me, do you want to provision this? Approve. Yes. Now, resource completion, operation completed, right? Now, if you go back now and list what is here now, do you see this file called daas file? It's even putting it in this thing, a mistake from my hand. You see a file called daas file here now, this file. And the content is what? Welcome. Do you see that now? So this is an example, but what I want to basically show you is not even this file or anything. What I want to show you is this. If you are very, very careful, I told you that when you run an init file, Terraform init create the backend, the the providers, and install a lock file, right? Now, basically here, first of all, you will see a file called terraform.state, terraform.tf state. Did you see this file? I am explaining Terraform state to you. This is what I'm working on.
Yes.
Now, if you open this Terraform state file, let us open this Terraform state file. What do you see in this Terraform state file? This is just a replica of what we have created. In this place, you will see it is putting the Terraform, the version, the Terraform version, the output. If I have any output, I do not have any output, right? Now, what is the resource that I'm creating? This is the resource type, local. What is the provisioner that is using to provider that is using to create the resource? What are the arguments and the attribute that is passed to that resource? You can see everything here. So this is a Terraform, a Terraform state file. This is how it looks like. So if I want to make changes to this file, Terraform will validate against what is in the state file to know what to change, what to add, or what to destroy. Am I making sense? Hello?
Yes.
That is what
Yes,
Terraform.
sir.
I'm going to change something, so we'll test it. Another thing that you see that Terraform created here is what? .terraform.lock.hcl. Here, this basically allows you to to lock your state file using some hash algorithm. So with this, the moment you run a Terraform plan, everything is locked. Terraform plan, everything is locked until you run your Terraform apply, and you can do a lot of state locking and so on like that. It's advanced, but let me just explain to you. This is what a state file is. If you know how to edit very, very well, you can make use of this. This maybe for example, in your environment, you have your Terraform state locked, people cannot unlock it and some other thing like that. You can, you can work with this, make some editing to this, this lock file, lock the HCL file, and find your way around it. This is just an example. Now, let us go back to our main.tf file. Now, I want to update my variables.tf. Now, I want to pass a default to it. And let me say the default now, the file contents now should be changing file content, right? This is just what I want to do, just changing file content, right? I'm not doing anything. I'll still leave this guy as daas. We call it daas file now, right? Daas file, right? .txt. It's fine, no problem. Now I have saved this. Now, if I come back here now, and I run my Terraform plan, you will see, what did you see? 1 to add, 0 to change, 1 to destroy, right? And it is basically referencing it against what is in our state file. Remember that in our state file, we have this guy, HC blah, 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 because I showed you this state file. You can see all these things are in the state file. So Terraform is making a reference to those state files to know what is being there. Now, what you will see here is that it is changing my, what do you call it? My old resources is destroying everything and changing it because it has to first replace some of these things. That's why you see that it is adding one and what removing one. So that is basically the way it was equally a state file works. So if I run Terraform apply now, TFA tells me, do you want to approve? Yes. Now it has created a new file for me called daas.txt. Do you understand this, please?
Yes.
So this is it, the simple way a state file works. Now, what do you notice here? There are problems that is associated with this state file. Number one problem is that share storage of state file. What do I mean by share storage of state file? Sorry, I'm coming. Share storage of state file basically mean that in this place, for example, you will notice that your state file is in your local system. Am I correct? Now, imagine someone want to make some changes to your state file. I'm sorry, to what do you call it? To your Terraform or your infrastructure. That person does not have a copy of what is in your state file, right? Does not have a copy of your state file. So in such a case, Terraform will find it hard to reference the right state file, and that person may probably create a new resources or have some issues with what is there. That's number one. Another thing is that another thing that can happen is that maybe the person is using maybe a whole Terraform version or something like that, which will automatically affect what you have created in your, what do you call it, in your infrastructure. That is number one problem with local state file. Another problem is state locking. Now, with our local state file, state locking is not really effective because what state locking should help you do is that maybe and who asked the question before? Was it Emmanuel? Hello? Hello? Can you people hear me?
Yes, sir, it was Emmanuel.
Yes.
My system is low. Let me quickly plug it. Sorry. 2 minutes. Just 2 minutes. Okay. Now, let's say, for example, I want to edit a file, and Emmanuel also want to edit that file at the same time. In that case, there will be a clash. Please mute yourself if you are not talking, please. In that case, there will be a clash between in that infrastructure because you and another person are trying to make the same changes at the same time. But with state locking, this is avoided. Now, how can state locking apply? This state locking can only work when that person has access to your state file. But now your state file is local, right? So everything you are running is local. In that case, that person cannot have access. So you may cause a clash or you destroy your infrastructure because you are basically trying to make the same change at the same time. That is another problem with local state file. Third problem with local state file is isolating your state file. For example, you have different environments and maybe production, dev, staging, and so on like that. You get me now? With local state file, it may be hard for you to, to achieve some of this isolation in a perfect way. That is what happens here. Now, what is going to be the solution? Somebody may say, is it not for everybody to have access? Okay, let's use Git. Maybe if I use a version control system, you can have access, we can say the same thing that we are doing. Everybody can, everybody can access the same file, blah, blah, blah. No, please don't use Git for your state file. Why should you not use Git? Number one, in a state file, your secrets are always stored in plain text. Even if you have encrypted it somewhere else, in your state file, it will always be in plain text. And if your state file is shared on Git, automatically it means that somebody that have access to your Git repository can hack your infrastructure. I have seen top companies where they do this thing. This is a error. That is why I call it Terraform the right way. Are you with me? Another thing is that, yes, you may say that, okay, state locking. Git does not help you achieve the issue of state locking, because in Git, we have version control system. So it will automatically be creating different versions of your terraform.lock.hcl file. Are we together? So now, what is the solution? That is where remote backend comes in. Now, remote backends help us to solve this problem. But first of all, what are remote backends? Remote backends basically mean that having your state file in an environment that helps to solve all your problem, and it is approved by AWS, I'm sorry, by Terraform. An example of remote backend, we can use S3 as remote backend, AWS S3. You can use Azure. Is it Azure storage or what they call it? Azure storage. We can use them as remote backend, and some Azure storage, Google storage as well, and so on. These are what we can use as remote backend. Now, it does not, you don't have necessarily need to use, AWS or anything. Depending on your business goal, you can use anyone. But what I do advise people is this: if you work with AWS cloud very well, use AWS for your remote backend. If you work with Azure cloud very well, create your remote backend on Azure cloud. If you are working with Google cloud, create your remote backend on Google cloud, and so on. It is what? It is good. It gives you uniformity in your infrastructure. Now, how does remote backend help us to solve some of this problem? Number one, it removes the issue of manual error, which I talked about, because in manual error, we have, what is it called? The people, people can easily, easily have access to, the same state file, and, maybe their Terraform version or something like that will not affect, because this time you are all initializing the same backend. And if somebody is using a lower version of Terraform, it will let that person know that, okay, this version of Terraform that you are using is not supported, or something is going to change. That person is going to see it. That is number one. I have had an example whereby someone on the system was using Terraform version 1.52. Another person was using Terraform version 0.13. And they both want to edit the same thing. But because of the fact that the person was using 0.13 and the remote backend the state file is in remote backend, that is stored remotely, he was able to see it and was able to quickly update his local Terraform version. Number two, state locking. In Terraform remote backend, especially AWS, we can make use of DynamoDB table, which basically helps you create a state lock by just creating a key called lock ID. So for every lock ID, you can lock and unlock your state using that particular Dynamo table. We have for us similar thing in Azure and other cloud providers remote backend. Thirdly, secret encryption. In cloud environments, your remote backend are usually in cloud storage, for example, X3. So what I mean is that X3 bucket automatically, for example, you can enable encryption for that bucket in such a way there is encryption at rest and in transit for your state file in that bucket, which basically means that even though the state file is in plain text, the data is encrypted because it is stored in what? S3 bucket. These are the issues that remote backend helps to solve. Now, this is an example of how to define a remote backend. In a remote backend, you use the same format Terraform, but this time, backend, you specify the backend, which is what you call it, S3. Then you put the bucket name, the key, the region where you have the S3 bucket. You also specify the name of your Dynamo table and also, add encryption to be true. So now we are going to create this in our AWS environment and see how it works. Any question before I create this?
No.
I hope you are all good. Thank you. Okay. Now, I have a file here. I'm going to explain everything to you. Don't worry. Okay. I have a file here called state setup. It's basically how I am setting up my, my Terraform state. Now, I'm going to explain what the file entails to you. It's very, very simple. You can see I said create S3 bucket DynamoDB for Terraform state. Now, what am I doing? First of all, I am creating an X3 bucket, right? Now, this is a definition to create the S3 bucket. The first thing that you see here is that I had life cycle to this place. And life cycle basically is that prevent equals to true. Which is that you can see when I hover, he said it helps to what? Prevent accidental destruction of the resources, just in case somebody run Terraform destroy by mistake. It will not delete these resources. That is one. Number two is that I also created a resources called S3 bucket versioning. This, in such a case, help you to version your state bucket. Look at this place, for example. Do you see state.backup? Do you see it here? Do you see state.backup here?
Yes, sir.
When I created the file before, I had a file. This was the file that I created before, right? That's file. Then I now created another one called what? That's file.txt, right? Here the content is changing file, but here the backup is what? Welcome. So by enabling, what was it called it? By enabling versioning for my S3 bucket, it means that I can revert back to my state at any point in time. This is important. I have seen environments whereby they create S3 buckets and they cannot revert back. I have taken a job that this has happened. I can tell you, I took in the job. I got the Terraform changes. I made the Terraform changes, made everything. Then Terraform apply. Boom. I saw the changes. I said, okay, it's going to make the changes that I want, blah, blah, blah. Only for me to run it and Then I got to know that some things were not even existing, some things were destroyed and so on like that. But on the long run, I could not revert because of the fact that their S3 bucket that they already provisioned was not versioned. Do you get me? So I could not revert. So I had to start doing manual work and so on like that. So it's important that you do S3 bucket versioning. That is why I splitted everything to explain to you. The third thing I did, you can see I call it S3 bucket server-side encryption configuration. This is basically helping you to use an encryption algorithm to encrypt your bucket. So in that case, which I explained, is that your data is going to be what? Encrypted at rest and what? In transit. This is what this means said. Now, also, I created S3 public block access. This is just to deny every public access to my what? My bucket, so that somebody that does not have access to my infrastructure cannot just, easily access my, what do you call it? My resources. So you have seen that doing this, I have protected the bucket. Now, how do I now work with the DynamoDB? Basically, I just create a DynamoDB table, calling the same name. The billing is paper request, creating what? A hash key called lock key, because I thought there is an hash key that we used before. In this place, I showed you an example of hash key that we have here. You see, this is hashes, right? Now, so now I am creating this guy, then I'm giving an attribute called, the table has an attribute called lock ID, and type S, and I'm giving the name. So this is how you will create an X3 state file and remote backend. So now let us do it together. Let's do it together. Making this up again now. Sorry, I need to take this up. Okay. So I want to create this remote backend now. So TFF, TF plan, and TF init, sorry. So now you can see it is downloading, it's initializing backend. This is local backend. It is initializing my provider plugin. Going to download some AWS provider plugin, and my initialization is what? Is successful. Now I'm going to run my Terraform plan. And now in my Terraform plan, what did you see? It's going to create all these resources for me: DynamoDB table, sorry, my S3 bucket, add those policies I created and so on like that. So I can run Terraform apply now. I'm going to go pass auto approve to it, so that it does not tell me to probably approve yes or no. So I'll just put it to that. So it's going to run it once and for all. So it's going to create it for me.
So, sorry to interrupt.
Yes,
Did you create aliases for this commands?
yes. I created aliases for it. That's why, yeah.
Okay, cool.
I explained aliases to you in the Terraform class, in Linux class. So I believe you understand.
Yeah. It's clear. It's clear. I just want to be sure. Yes.
So now you will see that this guy has been, what do you call it? Has been created. So if I go to my AWS environment now, and this is my AWS, let me just log in. If I go to my AWS environment now, if I go to X3, you can see I have an S3 bucket called what? Terraform states by Abi, and it's empty, right? And if I go to DynamoDB, I have DynamoDB table. I have this as well, you can see. So that means that part is successful. Now, don't forget that this is creating the state setup. this does not mean that you already have a remote backend initialized. So now we need to now create a remote backend, which is what I am showing you here. This one we did here is just to create the resources that you need for that remote backend. We're creating the bucket and so on. But now we have not told Terraform that, okay, for everything that you want to do now, put our state file in this bucket. We have not told Terraform. So to tell Terraform, we have to now add this to our configuration. That is where you will see that here now, I have a file called backend.tf. Let me uncomment this file. Sorry, Ctrl Z. So this is the same file that you have here. I will just save this. This is the same file that you have here. And now I am what? I am now telling Terraform that, okay, this time I want to be using this backend and, putting my state file in this backend. What we did initially was just to tell it how to create, to create the resources. But now we're going to give it the instruction to what? To create the backend. Now, because of that, you need to run your Terraform in it again. Now, what will happen here is this, because Terraform is smart. Terraform will ask you, we notice that there is a local copy of a backend before. Do you see that? Do you want to migrate that copy to your new environment? Because everything that I've been running before is locally. It's asking me, do I want to migrate to my environment? I say, yes, migrate. So now Terraform will then migrate and successfully initialize your environment for you. Are we together, sir? So so even if you run Terraform plan, Terraform command, everything, you will see it here. Now let's go back now to S3. Do you see now that there's a file called daas? And this inside that file, we have our remote backend state, right? So Terraform is smart to be able to create the migration from your existing backend to to your remote backend. That is what he has done here. He's migrating into your S3 backend. Now, what are now the limitations that we have with remote backend? Sorry, give me 1 minute. So, what are the limitations that we have with backend? Number one is that before you can create a remote backend, number one issue is that we have to create a local backend first, which is not, it is like a limitation that we have for it. That is number one. Because you will notice that I had to create S3 buckets, right? First of all, I had to create DynamoDB table, first of all, and those things already gave me a local state, right? You see, it's empty now because it has done some migration. This is backup. It's empty. Now, this local state that I have was then migrated to AWS environment S3. That is number one limitation. That is, you are creating local backend before creating a remote backend. Number two is that backend does not support variable declaration. Please note that, DevOps engineer, because everybody would think everything is Terraform is variables. No. Backend does not support variable declaration. So if you come here, and come and put maybe bucket name, come here and put var.bucket name, Terraform will flag it for you. This guy is not a good one. So backup does not support does not support variable declaration. Now, remember in the beginning, I was talking about some problems that we have, right? I was talking about problem of shared storage. Now, remote backend has helped us to solve problem of shared storage. You remember, right? Because everything is in the cloud and people can always, initialize the same backend, right? I also mentioned problem of lock ID, that is state locking. And now we have DynamoDB that can also help us with doing that, right? Then I also mentioned problem of encryption, and I also mentioned a problem which also has to do with isolating state files. That is, if you have many environments, how do you go about it? That is now what we're going to talk about now. Before I continue, any question? Ask your question. These are the basics. I'm not going to come and teach you Terraform, apply Terraform. I'm going to teach you the logic behind it.
Hello?
Can you hear me?
Please, you are muted. Somebody is talking, please. If you are not
Please, can you hear me?
Yes.
Can you? Okay.
Can you hear me, please?
Yes, I can hear you from Layo.
Okay. So I wanted to ask, like, if now that the the remote backend is set up, so if we have changes that we make to our files and all that, do we, if I think there was a time I was trying to work on it, and then when I make changes and then I have to initialize or something, that it will run into problems again, and then I think I was having to like okay, are there foreseeable, like now when you set up the backup and then the backend, right, and then you want to be pushing your new codes and maybe you made changes to the former ones and all that, are there any problems that somebody can face, like maybe there's a best practice to do it, the local the remote backend or not, please?
Okay, that's what I'm teaching you. Best practices. That's why I said the right way. In fact, please, when you want to post this video, post it with Terraform the right way, not introduction. These are best practices I'm teaching you. And like you said, once the problem that you can have with your backend, number one issue that you can have with your backend, I have explained, is issue of your backend not initialized. So for example, you might have issue with S3 bucket policy, so S3 bucket access. You can get access denied, for example, if you are using S3, maybe that particular user does not have permission to that particular S3 bucket or something like that. You can have such information. Maybe that particular user you are using does not have or tell that user assume that you are using does not have access. That's number one. Number two is that as far as your backend is initialized successfully, that is, you see this command, where is that stuff I showed you? This, where is it? This guy, initialized successfully, this place, Terraform has been successfully initialized. As far as you see that, other errors that could come up has to do with, maybe you initialize the wrong backend. It happens very, very well, because that is what some of this isolating state file comes in. Maybe you initialize the wrong backend. For example, you may have different environments and you go and initialize backend of test environment for dev changes. It happens very, very well. I think that answers your question. So in that case, people usually use backend config file, and you can pass -- the HCL config, because I told you here, the issue is this. This is where the issue lies. The issue lies here because here you cannot pass in environment variables to this place, right? You cannot, maybe you have different backends now. You have backend for dev separate. You have that backend for production separate. You have backend for everything separate. You get me now? But here now, you are just running Terraform in it. But you can still run the same Terraform. Coming, let me do something. I think it's dash backend. I'm coming. Terraform Dash dash help. Let me see. I think it's dash dash backend. Yeah, this is it. See, backend config. You see, you can see this place now. So in this place now, you can pass in the backend configuration file that I was talking about. So you can have different backends and pass it, and with that you can be able to use all these your key pair values, that is all those your variables. You can use it here. That is number one way that you can, that you can resolve this, which is like one of the ways that people usually use to resolve. Because if you go and initialize wrong backend, your changes will be done in the wrong place and you cause problem for your infrastructure, which is issue of isolation. And I'm going to explain that very, very well. Then another issue that can happen is issue of you not having versioning for your system, for your backend. Because for example, now, if I had a versioning for my environment, even if you make changes, you can tell Terraform that, okay, you can go to, what's it called? You can go to your AWS, go back to, because your S3 bucket already has versioning enabled. Sure, you get me? If I click on show version, because I did one here. If I click on show version, it will show me many, many versions, for example. Let us do something. So it will show me many versions of what I have. And if it shows me many versions of what I have, for example, then in that case, I can always, revert back to a particular version and redeploy my environment back. That is the issue that could also happen. So it all has to do with how do you initialize the backend? Are you initializing the backend the right way or the wrong way? Did I answer your question very well? Hello?
Yes, you did. Yes, you did. Thank you.
Good. You're welcome. So back again to any other question, please.
Yes.
Yes.
I have a
think
question.
Please ask your question, sir. I'm with you. One of you should go first before the other person. Maybe Emmanuel first.
Go ahead, Emmanuel.
I think it's off, so you can go on.
Okay. What I want to ask, I think I missed it. Where, as in this Terraform states, the backup. How did he come about the backup? I think I missed
It's
it.
automatically created. Automatically. It's a smart way for Terraform. But the thing is that maybe, for example, now, this backup is not going to have version 1, 2, 3, 4, 5. Maybe, for example, I make another changes now. It's going to delete the previous one and put this one there. You get me? So maybe you want to maybe go back to your infrastructure like in like 3 steps after some changes, like 3 steps behind. You cannot have that with local backup, but you can always have that with remote backup. That's remote backend.
Okay. So now what I want to because when you migrated to that the S3 bucket now, I noticed that I thought maybe the backup would go with it, just the way it is on the local.
No. It's only migrating state file. Okay. It's not migrating backup. It's migrating state file because now we have not.
So there would.
We only created the back end. What's it called? The state file setup. That is the S3 bucket and the what's it called? We have not done anything special than to create that resources. So the resources that it's used to do that is what it has carried with every existing backend and moved to what's it called? Move to the cloud. Hello?
Yes, thank you. I get it.
Do you understand clearly?
Yes.
So take, for example, if I probably provisioned an EC2 instance or a lot of things before I created this backend, it will move everything, the state file of everything, to move it to the cloud. Do you understand it, sir?
Yeah.
Yes.
Okay,
good. So any other question?
Okay, I wanted to ask a question based on the state file. Like, for example, now if you I'm a DevOps engineer and I'm in Nigeria.
I can't hear you.
So yeah, sorry. For example, now I'm in Nigeria now, and then someone is in. Okay, let's just leave Nigeria as a case study now. I'm in Calabar, and someone is in Lagos, and we are both working on the state file. how can I configure that on the using the state file inside the S3 bucket?
Like, I don't understand. You are both using the same state file, right?
Yes, though I've not done that before, so but I really want to
You
know
don't understand.
how.
Your location does not matter. As far as you are initializing the same backend, you
Yes.
cannot make simultaneous changes at the same time because we have a DynamoDB that helps you with state locking.
Okay, sir.
So even if you are anywhere in this world, even if you are by your side, you are on the same thing at the same time, one person will always take precedence before another person because of state locking.
Okay, sir. Okay,
You
sir.
get?
Yes, sir.
Good. That is why it is good to always have remote backend and not have what's it called, and not have local
The
backends.
local backend.
Any other question? So I think I answered this lady's question. The lady that asked about the what's it called, initializing backend that has to do with backend config. So I have given you an example that I can always pass your what's it called, backend config part, and it's very, very easy for you to what's it called, for you to go on with that. So that is the issue. So it's good that you initialize your backend in the right way. You get me? So for example, now maybe when I get to modules or anything, I can explain better for you. Is that maybe we have like 3 backends. Okay, which is good to what I'm going to talk about here now. Okay, look at this screen now. Can you see my screen? Here, I have staging, I have dev, I have production, right? And the issue is that isolating state file is an issue for people because people find it hard to get a best way to do it. Because if I make some changes now, in this, if I deploy maybe EC2 instance or anything that I want to deploy, for example, I will have my dev state, let me show you what I'm saying. Let me show you what I'm saying. I have here a particular resources. And in these resources, I am creating a VPC with an EC2 instance within that VPC. This is just going to create my EC2, my VPC, create AWS security group, right? Then create what's it called, an EC2 instance. You get me now? Now, imagine I want to deploy this EC2 instance into 2 environments, dev and production environments. Now, remember that here I am using var.name, that var.instance name, var.environment. You get me now? If I have my variables file, like this is my variable file, see that there's no default here. Here now, I can make use of a tf-var file. Let me open by the side to say that, okay, for my dev environment, make use of this CIDR block, this subnet CIDR, let the instance name be this, EC2 instance dev, and let the environment be dev. Then for my production as well, I can also have similar thing. For my production, and put it here, make it this CIDR block, make it subnet CIDR like this, and so on like that. This is an example. Now, if I am using the same backend file for this guy, this is what will happen. We have this scenario: staging, dev, production. In that case, it's going to be hard for you to isolate. Are you with me? It's going to be hard for you to isolate. And because of that, what people usually do is that they pass in the, what do they call it? The backend config part, like I've showed, like I responded to Formulayo, that you can pass in backend config part and have different backends. For me, for example, now I have WordPress application that I deploy, for example, and in my WordPress application, I have different website, like different WordPress websites. You get me? Because I work on a project that has to do with WordPress as a service. So they have millions of WordPress sites. Now, let me say I have like 3 WordPress sites. Maybe one is WordPress Israel, another one is WordPress in Singapore, another one is WordPress in Frankfurt. They have the same Terraform configuration. The same resources is deployed everywhere. Just like you have dev, production, and staging. But I can initialize different backend for them by passing in my backend config variable in my Terraform init command. So in that case, I'm going to write Terraform init dash backend config, just like I showed you in the when I ran the Terraform init help command. Then you specify your backend config file. That is number 1. The other 2 ways of doing it is working with Terraform workspace and Terraform file layout. Now, what do I mean by that? Let me explain to you. God. Okay, let me do this. So, for everything I've been doing before, if I run Terraform workspace show, you will see that I'm in default workspace, right? But in Terraform, you can have different workspace, making it easy for you to be able to isolate your state file. Are you with me? I say you can have different workspace, making it easier for you to what? To isolate your state file. What am I talking about? Let us look at it together. Number 1 is this. I created a file here called workspace a folder called workspace. And if you look at this folder, you will see some files which I just showed you before, which is the the variable file. This is my main.cf, like I showed you before. This is my variable file for that same workspace. This is my dev and production. Now I have a backend config. I have 1 backend config. You see this backend config. Now, what do you notice here? Number 1 thing that you will notice here is that this time I am using a different backend config key. You can see that this time is workspace dash, right? Now, what I want to do is I want to use this single backend for my dev and my production. And at the same time, I want to achieve state file isolation. How do I go about with it? Let's do that together. If I run Terraform init, for example, are you there? I want to do something now. Terraform init. This is going to initialize my backend for me, right? It's going to initialize that new backend for me. The new one I just did, this one, this guy. So let's hold on for it to finish. Let me take this guy a bit up so that, okay, you can see backend initialized successfully, right? Now, Terraform plan. Now, this time I want to pass, because I'm using TFVAR. Don't forget that I'm using TFVAR now. So I'll pass in my file name to it, my variable name. So let me say I want to do dev, for example, dev.tfvar. I've told you how to pass in variables to Terraform. I've explained to you. Let us see what it will bring out. In this case, anywhere it sees my distance, it will represent it with the value that I gave my dev environment. This is production. So you can see in dev now, it's picking the TFVAR for dev. It's going to create EC2 instance for me. It's going to create EC2 instances. It's going to create subnet, everything. My name is going to be dev EC2 instance and so on. Did you see this? Now, if I run this, sorry, I want to do something before I run it. I want to copy this guy. Copy. How do I copy? Sorry, let me copy something. copy this guy. I want to do something here. Paste. I'm going to rename it. Let's say default environment. Yeah, but let me say, no, let me call it default environment. Let me put it that way. All right, default environment. Okay. So this is my default environment. Let me just change this CIDR block to 12 to 12. And this is default C2, then default Ctrl S, right? All good, right? Clear. So before you do anything, always run Terraform format command. Terraform commands, it will help you format everything, help you format the indentation and that like that is good. So now I'm going to initialize again. Initialize successfully, right? Now I'm going to what now? I'm going to apply, right? Terraform plan, then dash var dash file is equal to this time I want to use the default. I want to use that variable default.tf right? Now okay, it is done. It is using my default, right? Dash 12 dash something. Okay, it's fine for me. So I'm going to apply now. Terraform apply. What am I doing? Skip. I don't know. My system don't angle. Okay, it's not a big deal. What can I do? Delete this. Create new terminal. Cd dash. Okay, the workspace, right? This is what I did, right? So now I want to apply. Right? I already know what will happen. So I'll just pass auto approve to it. Okay. What did it tell me? Oh my God. Okay. Sorry. I have a lot of AWS this year. Export AWS profile is equal to daas. I think so. Okay. I have to init again. Sorry. Because I opened a new listing. That's why. Apologies for that. Okay, good now. So now I'll just apply. Okay, now you can see that my resources is being created, right? I want to show you how state isolation works. Please, I'm taking you guys along so that we can all flow together, please. It's creating. Thank you. God bless you, sir. Amen. Okay, 4 resources created, right? Now let us go to AWS environment. Where's my AWS environment? Go to my S3 bucket, right? Now this time I have workspace, right? This is the new backend I created, right? This is the new backend I created, workspace, right? And if you go to EC2 instance, you should have 1 instance running. This is EC2 default, which is what we created, right? And the VPC should be in the, what's it called, in the VPC that we created, which is this, that's VPC that we created. I'll come in just a minute. Now this is the dash VPC that we created. This is the VPC that we created. Okay, good. Now this is fine. Now, for me to achieve state isolation, if I run Terraform state show like I told you, you will see that, sorry, not Terraform state show, workspace. Terraform workspace show. You will see that I'm in default, right? So a good way I can achieve state isolation is by creating new workspaces for my deployment, still using the same backend config. In that case, I can create a new one like Terraform workspace, new, let me say dev environment, right? This will create a new workspace for me. You can see created and switch to a new workspace. So if I want to switch back to dev workspace now, so if I run Terraform workspace list, I should have, is it not Terraform? Okay, Terraform, I spelled it wrongly. Yeah, thank you, sir. So I should have two workspaces, right? Default and dev, but now I'm in dev. So the same thing I did before, I can redeploy the same stuff here again, and it will go. That is, run Terraform in it again. This time I'm in a default, I'm in a dev workspace. You can see I'm running dev workspace. Then I'm also going to create the same resources, but this time I want to just use dev environment variables. Dev variable file, right? Dev.tvars. It's going to apply, it's going to create. I'm going to show you what I've achieved though. You will get it very soon, don't worry. This is my C2 instance. My VPC has been created, right? My C2 instance is creating. Okay, all created, right? Now, let me create another new namespace again. Another workspace. Terraform workspace, new production environment, right? -env. And now I will run the same stuff again, but this time I'm going to use production variables, right? Prod. Okay, now, if I run Terraform workspace show now, sorry, workspace list, sorry. I should have 3 workspaces: dev, production, and what? And default. Now, these are the 3 workspaces I have. What I mean is that, how have I been able to actualize state isolation here? Let us go to our state file. This VPC should now be many now. We should have many VPCs there now. You can see different VPCs. Go to C2 instances. We should have default, dev, and prod, right? Now, how have I achieved state file isolation? This is the way I've achieved it. Let me show you. Now, remember I am working with workspace before, right? You will now see that Terraform now created, because this time I'm working with workspace, but see, this is the state file I'm working with. Where's this case with backend? This is the backend. Workspace /daas-this, right? So this time because I'm now creating Terraform workspaces, it will create a new file called environment. And in your environment, you will now see your different workspaces inside it. Did you see? Now, it's created a workspace called dev.environment, production.environment. Then when you now click on this guy, you will now see your different state file under it. So if you go back to production as well, you will now see different state files under it. That is the way I have created state isolation using workspaces. Now, number one question is that I have 3 workspaces here. Why am I seeing 2 workspaces here? Number one is that this rule will only apply if you are creating anything outside your default workspace. So what I mean is that if I go to the default workspace, this is the default workspace. In this default workspace now, if I show version in now, this guy is if I download this file for you, this default workspace file, you will see the workspace that has to do with this default workspace variables for you, for me. You get me? So this, anything that has to do with default workspace, this condition will not work. But any other thing outside default workspaces, it will work. Now, what is the limitation of this first method, this first approach? The limitation is that, which is very, very obvious, sometimes you may forget the workspace that you are working in. That is just it, which is a big problem. And you just run, Terraform apply, Terraform init, and you destroy everything. That is just the limitation. So I advise people that if you are not very convenient with Terraform workspace, don't use this method. It's a good method, but I've given you the limitation. Any question before I go to the second method? Or the third method, sorry.
None from my end.
I'm explaining everything very well for you guys, so please, I want you guys to flow along. Now, let us go to the last method. I've talked about the backend ACL config method, which I used to respond to.
One question, please.
Okay.
So does it now mean that, so in practice, like we would not use default environments?
I don't understand.
So that,
what's your question?
Yeah, like in our example now, we are maybe because you want to show it to us too, we are trying to use the default default variables too. So does it mean that in the real world would have all our environments will have their names aside from default, so that they would always be separate from each other, and they will not have to be keeping like two on the console, like now where we have for default and then we have for the remaining environments? Did you get what I said?
No, I don't understand the question.
I understand her, sir.
Okay,
What she meant by that is that, like, for example, if you have like 3 environments, for example, and you have default, like let me use the GitHub as an example. You have the main that comes with the default now, and you're creating a dev environment, the staging environment, and the production environment. She's trying to say, in a real-time scenario, are we isolating the default environment? That's what she's trying to ask.
If you are using workspaces for state isolation, right? Right?
Yes.
Yes. If you are using workspaces for state isolation, then you need to always associate, go out of the, go out of the default workspace anytime. If you are using workspaces for state isolation, yes, that's correct.
Okay.
Some companies use it as policy. You get me? And what they do is that, I work for a consulting company, that what they do is that in their GitHub repo, the steps is that if you are doing anything in your, if you check their pipeline, you will see that for their pipeline has the following step. Before the Terraform init or anything, it first of all has a command called Terraform workspace new, then put in the variable, which is maybe dev or anything, which is a variable that is defined. You get me? Then
Great.
in that place, you can now start every other thing that it wants to do. So people do it very, very well.
Okay, thank you.
So it is good for computer users. For human users, it's not good. That's why I told you the limitations. But as a human, I will not use this because for me, I may forget where I am working. But if I have a pipeline that has been defined, that number one thing that the pipeline should do is that, always, just like you're telling that, CD to the right directory. You get me? Just like similar thing, go to the right workspace. So I will always, use this method for computer users.
Okay.
So that is it. Any question? Good. Now, the third method, using isolation file layout. This is very, very simple. It's not stressful or anything. Basically, what this means is that if you look at my directory structure here, let me clear ls-m. See this directory structure that is here now. See that everything is together. But this time, instead of doing this now, let me make a new directory, mkdir prod, then dev, right? See what I want to do. Now I will now copy self anything.tf, avista.tf. I will copy to prod. Prod. Okay, good. Then I'll also copy anything that has to do with start.tf to dev. Okay. Now if I now do go back here now, now. I have prod, dev, and this thing now. So what I will do is this. I will remove anything that has to do with start.tf. Now, what do you see here? I have, I did not carry this guy. Okay, no worries. What I have here is simple now. What I have here is that I have a directory called production, and directory called dev, right? Okay, let me show you this place better so you understand what I'm saying. So you will see here, I have a directory called dev here and production here, right? Production has backend main.tf variable and so on like that, right? Dev also have backend main.tf variable.tf. You get me? So then I can now put my variables file inside this place exactly. So this place, in this way, you can have state isolation by having this file arranged, just like arranging your file. And in this place now, you can now change it. Maybe your workspace will now be, maybe dev dash. You get me? Like dev dash. Let's do it. Let's do the example. Don't worry. Let's do the example. This is dev dash. And this is prod dash, right? Then what other thing is missing that I've not copied in the file? Okay, I've not copied this dev file to dev. Where is the dev file? Dev tf var. Put it in dev. Yeah, move. Then this is dev complete. Then prod tf var, rest prod. Prod tf var, move it to prod. Okay, good. Now, what I'm doing is this. So let's look at this. Let's look at my terminal. You understand what I'm doing? So you see, this is what I have now. I don't need default, so I just remove default if I want to remove it. So in this place now, okay, then let me remove it. I want to use default for another thing. So in this case now, I am isolating using, what's it called? Using file layouts. That is, I am having a different file or a different folder for my production environment, a different folder for my dev environment, a different folder for my default or anything. You get me now? So such a case, if I now come here now, and I come to say, okay, what should I do now? Go to dev now, cd to dev now. Maybe I want to deploy dev now. If I list what is in dev now, you see what is in dev now. I can run Terraform in it here now. It to initialize for me. Let's switch for it, please. Okay, initialize successfully. Then Terraform plan, right? Terraform plan, right? Right? Now, 4 changes to add because it's seeing it as a new thing because don't forget we are referencing a new what's it called, a new production environment stuff. I'm sorry, a new backend config. So that's why I'm seeing it. I don't know why my system is always hanging anytime. Okay. Okay. So now I'm going to run Terraform apply now, right? Right? Auto approve. You can see it's creating new things for me, right? It's creating everything fresh. This is state isolation using file layout. That is grouping your file based on environment. And in that case, you can have different, different state files in different location that you want it to be. So completed, right? So to do prod now, you have to go to prod now, right? And go and init again. Then we can, we can apply, right? Sorry. Prod. It's not prod.server. Yeah. Okay, sure, oh, sorry, I have maximum number of VPCs that I can create in my account. Okay, let me delete one VPC just to risk it. I'm just going to delete one VPC. If you want to learn about what happens, I can show you. I can teach you after the class. And just delete one VPC. Which one should I delete? Which one should I delete? I've created many 10.10.10. So let me delete this default. Come in, just delete everything. That's 62 instances running inside it. Okay, let me go to EC2 instance. EC2 instance and what? ENI, okay. So EC2 instance default, go and delete it. Show something quickly. Default. Terminate. Okay. And VPC now. Okay. Okay, still shutting down. Oh my God. Okay, just a minute. Just let this guy shut down. Finish quickly. Instances.
You need to allow Grace to shut down before.
Yeah, I know. Okay, it's terminated now. It's terminated now. I want to be fast, that's why. Okay, it's done. So delete here. Delete everything. Okay, good. You're fine. So now we can go back here and run the same thing again. Terraform, apply. Then, right? Good. Yeah. Let's see. Okay, schedule a VPC now. Good. Schedule everything again. Okay, good. Now, let's start go here now. Let me now show you what has happened now. And if you go to our EC2 instance now, we should have 4 EC2 instances, 2 prod, 2 dev, right? One we use state and workspace to achieve, right? And the other one we use file isolation. So how will we distinguish it? Go to S3 now. This is where we distinguish it now. So I told you that for workspace, we have a folder called env, right? But for state isolation, we have different things. See, this is state isolation. So this is file layout isolation. See, did you see this? Did you see this? This is prod. So directly you see prod. This is dev. Directly you see dev. I hope you get it. So this two is using file layout. Now, what is now the disadvantage of this guy? The advantage of this guy is that number one, you need to always go to a particular directory before you can run it. That's one. Number two is that you will have multiple files unnecessarily. You can see here, I had to copy the same thing into the same places, right? This is the same files, right? This is disadvantage of this, what you call it. Now, the advantage that it is, and also the issue of what's called disadvantage of copy and paste, because if you are not careful, you may do some mistake with copy and paste and so on like that. That is it. Now, the advantage is that you can see that your code is clean, and the layout is also nice, and you can you can achieve your what do you call it, your association. Sorry, you cannot achieve your your isolation in this way, as you can see here. So this is where I will end today's class for. Maybe later in the week we will get to talk about the later 2 parts, which has to do with Terraform modules, working on how to use a good reusable Terraform modules, and also how you deal with secrets in Terraform. My assignment ahead of the week, number 1 question is that I have given you 3 methods of isolating state file. Which one is the best? Everybody come and discuss and let me know the reason why you feel which one is the best. Then aside that, I will send other assignments regarding backend file. I'll send it to you later during the week. Thank you so much. Thank you, everyone. Any question? Hello? Hello?
No question.
Okay, no,
Thank you
for
for
now,
your time, sir.
for now, there's no question, sir, at my end. But the point is that, okay, this is not like models, because I'm seeing dev environment and production
I did not tell you
environment.
that this is module. I give you a slide. I'll come back and teach Terraform module next week.
Okay, sir. Okay,
I showed you
sir.
this, that this is Terraform node. There is another class. We have Terraform module and secret management.
All right, sir. Thank you, sir.
You're welcome. Any other question? Okay. Thank you so much. Thank you, everyone. And this Terraform is not just Terraform. If you know how to use Terraform, you will know how to use Terraform. Now, I'm going to end it with something. And also, second assignment, please, I notice people that are here. There are some other tools that we use alongside Terraform, especially when you're having complex, oh, let me share my screen back, sorry. Especially when you're having complex environments. Are you there? Because, for example, in this file layout that you have here, imagine if you want to run production and dev, you want to run everything together at the same time. You get me now? For example, I'm just saying, it doesn't have to be production and dev. Maybe you have like different WordPress application, like I told you. Maybe you want to make the same changes to Singapore, Frankfurt, and this and like that. You can use tools like Terragon to help you achieve this. You get me? By using Terragon is an external tool that is like an abstraction of Terraform. By using Terragon, it is more easy for you, and Terragon works more when you have modules. Sure, you get me? You can see in this side, you can see in this slide, these are different Terraform. All these things I have are Terraform environment for these things. And when you have more, what is it called? When you have more clusters, more environment, you have, a lot of things to deal with, which, can be difficult for you to manage. So if you have tools like Terraform, there are a lot of Terraform tools. You have TerraGrunt, we have Terraformer, we have TerraVision, you have TerraTest. You can go and read about some of these tools. They are going to make your work easy the more you know how to use them. I use TerraGrunt a lot. And at the same time, I will also tell you that some of the issues of all these open source tools as well is that we also have Format 2. Format 2 also helps you to, convert your Terraform code base into, to create a Terraform code base from resources that have been deployed on the internet already, like on the cloud already, maybe manually, and you need a Terraform code base for it. So the issues with some of these open source tools is that you need to be security conscious, which I'm going to talk more about in our next class, because some of them you have to provide your access credential and some of them to this environment, and they can in one way or the other do unnecessary things they're not supposed to do in your infrastructure. So whenever you want to use any tool, it is important that you work with as many as possible and review the security issues that that has to do with some of these things. So, but next time we'll come back and talk about modules. You really enjoy it. I'll show you how to create modules. This is an example now. I use this. You can see I have a lot of Terraform modules that I use for different things, different things. You get me? And at the same time, I will also be able, this is another Terraform module as well. This is like, you can see this is like modules. I have a lot of modules that I also use. There are a lot of things. So at the same time, I'll also let you know, what are the best way to go about with some of this module creation, and in here that you can reuse modules as much as you want. So that is all. Thank you. Thank you.
All right. Yes.
Oshe.
All right. Thank you so much, Nurudeen.